Hello, my name is Leslie, and today I'm going to teach you how to graph and also analyze a titration curve. And this one in particular is showing the titration curve of an unknown buffer. So what I've done so far is I have two data sets. One is I titrated this unknown buffer with NaOH, um, which is sodium hydroxide, and I've added different volumes of the base, and then I have the corresponding pHs. And I did the same thing for HCl. Um, these are different volumes of HCl that I added, and then their corresponding pH. So recall what a buffer does. It maintains the pH at a certain range, and it also has like a certain capacity. Um, in summary, what it means is that every single buffer is going to maintain the pH at a certain level. It can be really narrow, like with contact solution, it will maintain the pH at 7.4. Um, Another strong buffer that we have in our house is like Alka-Seltzer. And then there's also weak buffers like the buffering system in our blood. That's also a very narrow range. There are some buffers that will maintain the pH at a greater or broader range, like say between 5 and 8, or like 4 and 5. The buffers in our stomach will maintain the pH at about 2 to 3. So buffers have different buffering ranges, and that's the range in which it'll keep the pH somewhat stable. Every single buffer also has a capacity, and this basically describes the strength of the buffer. We can have really weak buffers like our blood buffering system to very strong buffers, like I mentioned before, contact solution, and then also like Alka-Seltzer, Maalox, those types of things that we have around the house. So what we're going to be doing here is we are going to graph these points. We're going to create a titration curve, and then I will help analyze it with you. Okay, so it doesn't fit all in one page. So I just want to point out that this side is going to be the mils of NaOH, and this side HCl. And as you can see, in the center is 0. So the center is 0. That's 0 NaOH and 0 HCl. That's basically what the pH of the buffer is without anything. And then going out this way, we have the different volumes that we added. On the y-axis, we have the pH. Okay, so let's go ahead and plot that. I'm just going to try to get the data in here. So the first one to plot is at 0 NaOH, the pH is 5. So we'll go here and then go up to 5. I'm kind of looking at it at a weird angle, so you have to... Okay, and then let's see, 2 mils of NaOH will be 5 again. And then 4 is 8. All the way up to 8. Just, okay, right here. And then 6 mils, we have a pH of 12. And then 8 mils, we have 12, 10 mils, 12, and then 12 again. Okay, so now we're going to go to our HCl side, and this is on this side. And then let's see, we still have a 0 HCl is pH of 5, which we'd expect. And then 2 mils is 5 again. And then pH of 4, we have 4. I mean,
someone's here.
Okay. Okay, I went ahead and did the other 2 points. I had a visitor, so in a mask and 6 feet away. So I'm just connecting the lines. Okay. So as you can see here, we do have a buffer here because it is maintaining the pH at a certain level. Now let me just show you this picture here. This is from your lab manual, or I guess you don't have on this term, but this is from the lab manual, and this is showing a just like a something like water where there's no buffering capacity. And so what you see here is that, do you see how there's two plateaus here? Do you see how there's like two flat parts of this curve, but they're up here at pH of 12 and then they're down here at a pH of 2. So two big pieces of information is that the pH of NaOH is 12 and the pH of HCl is around 2. So you cannot go over 12 if your maximum is 12, right? And you can't go under 2 if the minimum is 2. So keeping that in mind, you can see that this is like water because as soon as you start adding any, so water's pH is 7, so here's that first data point before you add anything. As soon as you even add 1 mil of NaOH, it shoots up to 12 and then just keeps it at 12. Do you see that? And then down here, the same thing. At 0, it's just a pH of 7. But then as soon as you add 1 mil of HCl, it becomes the pH of HCl. So this is no buffering. This is a titration curve for solution with no buffering capacity. Now this, on the other side, this is a buffer. This is a titration curve for a buffer with a moderate buffering capacity. Okay, so what we're looking at here is that instead of just this straight line that we see here, in this range here, do you see a straight line and then it just goes 2 or 12? In this case, we have this right here. Do you see how there's a flat line here? This means that it is buffering, that it is a buffer, okay? Now you still see this flat point up here at 12 because the pH of NaOH is 12. So it's going to, it might reach this point, but it can't go over it. The other flat point you see here is over here where it's a pH of 2, which is the pH of HCl. So this right here is where the buffer is maintaining the pH. Okay, so let's go ahead and use this, and then we'll go to our graph, and then I'll show you another one. Okay, so the question is, what is the buffering capacity and the buffering range, or the pH range? Okay, so what you're going to do here is you're first going to determine what part of this is not, which flat part is your actual buffer, like where your buffer is actually working. Okay, so we talked about how this is the pH of NaOH, so this is not the flat part that you're looking at, and you're not looking at this part either. Okay, so what you're actually looking at is this here. Okay, I call this glass ceilings and glass floors. You can't go over this because this is the pH of NaOH, and you can't go under this because this is the pH of HCl. So essentially what you're looking at is, look, the buffer is not working. It's the pH of the substance that you're titrating it with. So what you're actually looking at is here. Okay, so the next thing you want to identify is the last part of this flat part before it stops acting like a buffer. Okay, so you're going to look at this flat part, and as soon as it starts to kind of drop significantly, that is your last point. In this case, this would be the last point here. And then in this case, see, so it's flat, 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 flat. Oh, what's happening? This is like the last flat point before it stops acting like a buffer. Do you see how it's like, okay, well, I'm going to maintain the pH here, but then after that, it shoots up to 12. And here it shoots down to pH of 2. Okay? The next thing you're going to do is you're going to draw lines to the x-axis and then you're going to draw lines to the y-axis. Okay, and this will give you your the two pieces of information that you need. Okay, so the first question is, what is the buffering capacity? Okay, so the capacity is how much this buffer can handle. Okay, so the buffering capacity is going to be this part on the x-axis. So in the case of NaOH, the capacity is going to be around 2 mils of NaOH. And the capacity of HCl is going to be around 3 mils. Now again, what this means is that this buffer is functioning until you start adding more than 3 mils of HCl or 2 mils of NaOH. After that, this buffer no longer works. The other thing you need to determine is the pH range. So when you draw the lines over here, it's about, I don't know, like 6.5 maybe to about 8. So the pH range, whoop, is going to be a pH of about 6.5 to 8. Okay, this means that this buffer is maintaining the pH at about 6.5 to 8. Okay, all right, so these look better than this one. All right, so let's evaluate this graph, the one that we just made together. I didn't draw the line very well. I'm not an artist, whatever. You can deal with it. Okay, so why don't we find out where our glass ceiling and our glass floor is. So we're going to look at this graph and we are going to X out the flat parts that are the pH of the things that we titrated it with. So we titrated the pH of, so that let's just say the pH of NaCl is around 12, and the pH of hydrochloric acid is around 2. Okay, so up here we're just looking at the pH of hydrochloric or sodium hydroxide. So we cross that out. That's our glass ceiling. Okay, I like to call it the glass ceiling. And this down here, we're looking at the pH of HCl, so this is not what we're looking for, and this is the glass floor. And what that means is if you have a glass ceiling, you can't go past the ceiling, even though you can kind of see through it. And then the glass floor is the bottom, you can't go below it, okay? So what we're actually looking at is this part right here. This is where the buffer is maintaining the pH. So what you want to do is you want to determine that last point on that flat part before it stops acting like a buffer. So what you're going to do is look at this flat part, and do you see how this point right here, from this point it just shoots up? You see that? And then at this point down here, this shoots downwards. Okay, so this point right here, this is where our buffer is actually working. Okay, so what you're going to do now is you're going to draw lines that go down to the x-axis and then to the y-axis. Okay, and then this one. Okay. All right, so let's first determine what our capacity is. Okay, so we have our buffering capacity. Okay, oh, sorry, it's all right, and this is going to be a volume. Okay, so we there's going to be one for HCl and then one for NaOH. Okay, and so the capacity for HCl is going to be here, which is 6 mils. And then over here is going to be 2 mils. Okay, so that means that after you add 2 mils of NaOH, it no longer acts like a buffer. And then once you add 6 of the HCl, it no longer acts like a buffer. Okay, now let's look at the pH range. And this is the pH in which this buffer is maintaining. And it's going to be on your y-axis. So it's going to be about 4 to 5. So it's going to maintain the pH at about 4 to 5. Okay, now the next one, I want you to look at this and I want you to analyze it, and then we'll do it together. Okay, so after I show you this next graph, I want you to kind of freeze your screen and, sorry, let's do this so you can't see the back part here. I want you to freeze your screen and I want you to determine what the pH range and the buffering capacity, which is going to be mils, and I want you to calculate or determine the pH range as well. So go ahead and pause that, please. Okay, so let's first determine, okay, so again, the first thing we're going to do is determine the glass ceilings and the glass floors. So here we have the glass ceiling because the pH of NaOH is 12. And then down here is the glass floor because the pH of HCl is 2. And so what we're actually looking at is this part right here, okay? And this one's a little bit curvier than the last one, so it's going to be a little bit difficult to determine, but we'll do our best, okay? So let's look at one end of this flat part of the curve. This point right here looks like it's right before it starts to shoot upwards, and then this part's a little challenging because I would say around here, okay? And then so what we're going to do is we're going to draw from the points to our x-axis and then out to the y-axis. Okay, so this graph is not very good looking. Yours will look better than this. Okay, so the pH or the pH capacity, and then we want to do the buffering range. Okay, so the buffering range is going to be 5 mils, or let's do NaOH first. Well, it's going to be 3 mils of NaOH and about 5 mils of HCl. And then the capacity is going to be between 4.5 and looks like 6. So 4.526. Okay, so that is that. Okay, so just as a quick summary, we talked about what a buffer is, and that's just a substance that maintains a pH at a certain level. There are two components to a buffer. There is how strong a buffer is, which is the capacity. And then we also talked about the range, and that is the range in which the buffer is maintaining the pH. So buffering range is what you would find on, wait a second. What am I doing? It's a buffering capacity in the pH range. What is going on? Whew. Wow, I hope one of you caught that. Probably all of you. I apologize. So the buffering capacity is how much a buffer can handle, and that's going to be on your x-axis. And then the pH range is going to be the range in which your buffer is working to maintain the pH, and that will be on your y-axis. Okay, so the next video I'm going to do is I'm going to teach you how to